Well, good morning, everybody. It's happy to be here, and thank you all for joining. I see the room almost emptying up, but let's not get worried about that. My name is Kyosti Laiho. I'm based in Helsinki. I usually use my nickname Köppä all over the place in Finland, Koppa in other countries. I've been working in the industry about 30 years, 6 years in consulting at Accenture. Then again, it was Andersen Consulting at the time. I worked for about 15 years in a startup company in database area, both in Europe and in Silicon Valley. And then IBM acquired the company, and now I'm at IBM. I'm an engineer from my background. I'm a technical guy. I'm a relatively simple guy. If you ask my wife, she would certainly agree. I don't use much complex words like leveraging synergies or digitalization or something like that. I try to keep things simple. So if you ask questions on the way, please try to keep them simple. That helps me as well. Okay. Currently, I've had quite a bit different hats on the way. Right now, my role is a sales leader for database area for IBM in Europe. I'm based in Helsinki, probably because it's in the center of Europe, right? But kind of happy to be here and listen to the discussion here. Everybody's saying it's so data-centric. That just means to me that you guys will be buying some more data management software sooner or later, because you will be using it much, much more on the way. I thought of seeing the themes of the event, first time for me to be here. I could do a sales pitch on IBM, different things. I could do a technology wrap for you, but I thought I'll stay a little bit away from that and perhaps throw in some reflections, having worked in multiple continents, a lot of customers on the way, about what does it mean to be data-driven, and what's the reality for all of you guys. I know it's a damn complex area. My hat's off to you surviving with it. So I'll try to cover that a little bit as we move forward. So the theme was kind of related to AI advanced analytics, data science, artificial intelligence. It's clearly here today. It's been here for quite a while already. It's increasing. But the reality seems to be still that while building AI, collecting data, categorizing it, analyzing it, feeding that into models for machine learning and something is pretty complex stuff. You hire high-end skilled people, doctors and so forth, because the algorithms and the mathematics behind it is damn complex. Still, 80% of the work is just trying to survive. Do I get access to the data? Can I actually get a copy of it? Do I understand what do I have here? That's 80% of the work for the very high-end, perhaps even highly paid guys, teams. So there is obviously a mismatch, and just thinking, where is it coming from? Let's a little bit look at that. The other thing I seem to be seeing all the time is the marriage between business and IT. Every business you run, where you try to make some real volume, cost efficiency with that, needs IT, and that has been around for 30, 40 years already, increasing all the time. They are just completely married together. Kind of reminds me of time when my wife and I were young couple. My parents threw in a Christmas party. We chatted with an old couple in the line for waiting for food, and we just casually asked, how is it going from that old couple. And the man said, my wife still doesn't understand me at all, and she doesn't trust me in anything. And the more I thought about it, later, now after 30 years, I seem to realize that the trust and the understanding between two people in a marriage, talking to our friends over the time, that gap has always been there, that will be always there. Seeing an old pair or any pair in a grocery store in the line, you tend to see the same phenomenon. He doesn't understand her and she doesn't trust her in any matter. Okay? That's a fact of life. If you think about the marriage of business and IT, have you ever come across that one doesn't trust the other or doesn't understand the other? Well, that's us. It's human. It's there. I actually wouldn't be too worried about it. It's there. It's in us. Look at the mirror. It's in our genes. So, try to survive with it, live with it. But it's there. It will never go away. So while you think it's troublesome, you are struggling with it, that's how it is. It will never go away. The other thing I want to also focus on, because I think we are a lot of talking about the new things here, AI and data science and how you build that, how you organize that and so forth, is the connection between your legacy IT and innovation. None of us will survive in business unless we innovate a lot. I'm really happy to see the evolution of startup companies in Sweden, in Finland. A lot of good work going on, a lot of innovation going on. At the same time, when you build a business and you build the IT for that, you have to consider that as a factory for the IT. You optimize that. You have to make your bulk of the business work really well. That's where the money comes from. That's where you service your customers. At the same time, when you innovate, a lot of that will need to take place, a lot of that will fail. But the parts that actually will succeed and you will adopt it, always look at how do I then integrate this? How do I run this in real production? If this becomes big, it becomes volume for me. How do I then do it? So while the innovation is needed, it doesn't always succeed, but the parts that you will actually end up using in production, always look after, if you are an architect or senior guy, and look after how do we actually get this up and running, integrate into our business operations. The things that people actually use. Will it run in production with volumes? That's an area where a lot of people seem to be missing because we like to adopt so many new technologies alone. But the next step after that is kind of crucial. Otherwise, that innovation that would be otherwise excellent may not really work very well for you. So that's what I was kind of a little bit, thinking of. I'll address some of the topics on the way. First, perhaps a couple of history bits. Those who have been here for a little longer, like me, the databases have been around for quite some time, right? 30 years, 40 years almost, okay? It started from OLTP databases, and then there was an evolution towards data warehousing. Let me just address a couple of slides, where that actually came from and why did that happen, because that is part of what we are discussing here today, in overall. There was a business application. There was a database serving that business application. There was online users, OLTP users, using that, hoping for relatively fast response times. Well, once that was optimized and get going, you actually started realizing that, well, I have some good information in that system, in that database. Let's run some reports out of it. And that started consuming more resources at the time when computers weren't that strong as they were today. And, then you added some more complex, heavy reports. The more you have business use, more you have customer data there, the more you have real information, of course, the more you start using it. And then people started realizing, well, we can't survive with this. The computers aren't good enough, the databases aren't good enough, and therefore let's do something else. And you try to add capacity, you try to manage the workloads, whatever you needed to do, but you did a lot of work, but still the thing that happened was an introduction of a concept. Well, let's get a copy of that data from that online business application into a data warehouse, which was actually a smart thing to do because you separate the very heavy workload, the analytics, the reports, from the part that was actually running your business. It's quite some time ago when this happened, but it's been out there now for a long time, okay? And then you came up with an idea that, okay, let's extract the data from the business application databases, let's transform that into something that works better with the reports, let's load into a data warehouse, let's optimize it, build some data marts, some material, cubes and so forth, just to get your reporting performance because suddenly you had a lot of data you need to deal with, okay? This is pretty classic approach of, ETL, data warehouse processing. Well, the reality looks something like this. This is from a customer presentation. This is an application map that happens over the time after some couple of decades of buying, deploying applications for your business. Okay? This is the reality that I believe many of you either dealing already or will be dealing as your business matures. For the next 5 years, for the next 10 years, you keep deploying new applications. Here's probably what you are doing. And here's where the real problem begins in my mind. This is a real situation. Then when you keep on copying data out of these systems, you start wondering, I have the report. Where did this data come from? And this is what it looks like. You start working on the data lineage. What's the source? What's the outcome? And this is again from a real customer slide here in the Nordics. If you just look at the numbers of somebody trying to manage, design, implement, organize this, put some tools around it to survive, this is what we are really talking about in many cases in the large organizations and small organizations growing to become a large organization. It's a complex task. And now if I go back to my first slide wondering why on earth is it so difficult to get the data into some other use, here is the reality in my mind. It's damn complex area, and you have so many systems, you have so many sources there, and some of those systems have been acquired quite some time ago. IBM is a large company. We've been deploying a lot of different applications over the time. We were complaining to one of our managers that, look, these systems are crap. They just don't do anything for us. And the answer was, look, any given point of time, 40% of anything that we did in the past is probably today crap. We can't fix it, deal with it, live with it. There's no other way. This is the realism in my mind, in many companies, even mine. So while we think that we have optimal systems, let's just do governance and everything is fine, it's not that easy, not in my mind. There is some old stuff, there is some current stuff, there is some new stuff coming in, and somebody needs to look after everything. I don't think that's going to be a realistic task to do perfectly. So you try to cope with whatever 80-20 rule and try to do the best out of it. But really the bottom line is that I don't think you're going to get away with this. You're going to have to do this anyway. But there is a whole lot of things you need to look after, given the amount of systems, given the amount of copying of the data, given the amount of management, governance that you need to put together to actually implement something that leads into a data lake or data warehouse or foundation for data science or artificial intelligence. There is quite a bit of work, and I wish you luck surviving with it. But I don't think you can get away with it, so better move forward and do the best out of it as much as you can. Use the tools available, put in the effort needed, but don't try to think I'll manage all of it. I doubt you'll survive with that. Nobody will. Okay? So really, I think the question today is, okay, we have a lot of applications. There's a lot of customer data, a lot of product data, a lot of profitability data, a lot of this and that helps your business. But how many copies you really want to have out of that data? Because that leads into a lot of management, a lot of design implementation. So I think you have to do it, but don't overdo it, because that will just lead into more work over the time and more challenges in managing that life. So I think what you need to do is to find a better balance in terms of copying the data, managing, governing it, and then what if you were able to go back to the source of the data and use it directly from there? If you think about, you have exploration type of tasks, data science, somebody wants to take a look, what if we analyze this data? Why copy all the data every time for that? Why don't you go to the source and do that one time, 2 times, access to that? If that then turns out to be something really good, going all the time to the source may be too much capacity consuming. So then you want to copy it for further use and keep it updated. But that balance, probably makes sense quite a lot. So one of the options, if you remember, the original problem was that the source system couldn't have the capability to cope with the load. What can you do to that, perhaps? To give them more capacity, give them more power. Of course, you can buy bigger boxes. That's always a good solution, because then you have more capacity spare there and you can throw in some extra accesses there, and that's what the analytics guys will be wanting to do. I want to go there, I want to browse through all the data there, I want to try this and try that. You need some extra capacity there, so buying a bigger box is always a good option. You can of course buy a better, higher-end database solution for that actually scales both up and horizontally scales out. Those solutions are out there. There are also some really good integrated appliances. Some are very expensive, some are affordable, but that's always one option, that buy a system that is optimized for high-end computing, both for the computer side, the memory size, the storage, but also the database technology-wise. If you go with an Oracle or Teradata, good boxes, but very expensive. If you go with SAP HANA, most expensive of all. But these are available. It's always an option as well to look at. Okay. I think one of the emerging technologies past 5 years has been the in-memory columnar database technology for analytics, for reporting. It is something where the data is there in the similar fashion in a relational format, but it's organized inside the database to be more vertical-oriented accesses, because that's how the analytics, the reporting usually use it. You may gain 10x performance easily with that for the same data. So, if you look at, I need a high-performance solution, then something like that definitely makes sense to look at. Then there's the new stuff, the NoSQL, the Hadoop, the object store, event stores that are kind of designed for more open, free access of all kinds. Some of these are saying, well, let's use the commodity hardware, it's much cheaper. Some of them are a little bit more specialized pieces of technology for a certain purpose, like real-time event processing. But these technologies are there, so you have different situations, different backgrounds. There are solutions for that, so you need to take a look at which of these actually make sense for which purpose. Blockchain is emerging. Again, it's a distributed data management platform that may be a solution that you don't copy the data, you have accesses different places, and that's integrated between different organizations even. These things may make sense, but I don't think that really removes the problem that you need to manage the data and you need to govern it so that you can actually really use it. In many cases, still making more copies. And then, of course, the ever promising cloud that gives you everything in no time at no cost. Feel free to use it. And I think it is just another gimmick, if you ask me, that it's a platform. It may be lower cost, it may be better agility there in terms of developing new things, because some of the data centers are just too paralyzed for delivering new environments quickly enough. But I think somebody was talking earlier here about the business cases and the value of different things. That's what I do for a living. I always try to figure out, well, if this is what you want to do, what actually makes sense, technology-wise, but also money-wise. If you implement this is the impact, and here's the cost. Where was the value? Did you get something out of it? And I think that goes for many of these technologies as well. And Hadoop is right now relatively important. It was introduced already quite some time ago. It's 15 years old technology. I think it's important perhaps to use it today. But I think there will be new technologies that replaces that. That's the nature of open source. New things come along all the time, and they are usually better things. They are better fit to something. But the interesting thing is, I think you'll be using a lot of these in the future. So the question is how you integrate all of it. Databases haven't gone away. They may be complete legacy, but they keep increasing all the time, the amount of usage. Same thing will happen with many of these. So the real question is, how do you use the best out of these in different situations? Another thing that seems to be increasingly important, especially in the data science, in the AI area, is the data virtualization. There are some new technologies coming along where you can, instead of copying the data somewhere, you want to use it from one point, from one application, one place. Can I go to the source data easier than I can do today? Kind of federated Excel, distributed queries, there are different names for this, but basically what you're talking about is your application access point of view. In virtual fashion, can go into different databases, different data stores seamlessly. And this makes it easier. Instead of managing the copies of the data, you go to the source and access it from there. The better tools you would have that, the faster access you have for going forward. And if needed, innovate something, fail fast. Do the research, give it a try, see how it works. Did you learn something? Is it useful? Then you decide if you go forward or not. But that virtualized data access gives you freedom to do it faster, because you don't have to worry about, do I have to copy which parts of the data, do I have to do a transformation to understand, is this customer data, is this and that what I'm looking for, and how do you then get away with that? I think one of the best things you probably can do is, however, to think about the architecture of the different components. And I think this is where I would put some more effort in terms of thinking, how would I implement the best possible architecture for using the data? I think a lot of the classic business applications, your transactional data has the most valued data inside the organization. It's there, it's probably a fair amount of unused for some new good things, because they are targeted to serve a certain business application purpose. But the data is there. I think you should use it more widely and more, more wisely as well for new stuff. But then the question is, how do you integrate that into some of the new stuff from the social media, from the IoT, from internet and so forth? And the architecture for building data lakes or adopting different new data sources. Where do you do data science? Where do you do some business reporting and so forth? To separate, to architect those elements, I think that's one of the keys where you survive for the longer term, with the different innovations, with the different changes that will take place. Whatever you do today, 5 years from today, maybe you have different systems. It may be that your business has changed a little bit. You are adapting all the time with the direction, so the architecture will help you guide through that process, because you don't have to change everything if the key components are there properly designed. So this is where I would, spend some time trying to figure out, how do we do this when we do some new things? And I guess one slide here, since I work for IBM, I'm a sales guy, so, sales pitch slide. This is IBM's Watson AI architecture. The theory of doing AI platform and which tools to use. It starts from collecting the data, organizing the data, kind of what we already talked about. It's far more complex than presented here, in real life. But that's the fundament. I think it was already talked earlier today that if you try to put artificial intelligence to something that is data is crap, well, you get a crap output. It's the same thing that 10, 15 years ago when people were talking about, let's build some processes, let's become process oriented, and let's then automate that process. Well, if the process is crap, what you do is you automate the crap generation. You get more crap faster. So that doesn't really work out too well. Same thing works with the data in my mind. If you don't take care about the foundation here, this is the fundament, the outcome will not be too great in my mind. So you need to spend a lot of time, and I think the proof point, 80% of your time goes into trying to survive there, is just a fact of life today. It's like, when my kids were a little bit younger, played a lot of, games. My wife told them, go and get them to the dinner. And what I had to do after 2 hours of, playing session, drag them out of the room saying, welcome back to this world. Time to have a dinner, time to do homework. It's a little bit same here, that you can always dwell too deep somewhere and, in theoretical level, go somewhere and, think this is how it really is. No, the real world is here. And that's what we all need to address as we go forward. So, once you have that, then you can, build whatever organizations you want for the data. You can catalog it and so forth. There are excellent tools for that by IBM, by others as well. And then you can start looking at, well, where do I go with data science? Where do I go with AI? How do I start building those models for my machine learning and make really good things out of that model? But, managing that foundation, in my mind, is absolutely the must and the key. So try to keep the data architecture, the information architecture in your organization, in a reasonable fashion. Architect it well, and then basically you give the tools to build something new, and you can integrate the existing with the innovations that will be also taking place there at the same time. All right, I think that's what I was kind of thinking of discussing. Not too much, IBM pitch, I hope, but just a reflection of what I've seen in 30 years in different continents at different customers. Thank you very much.